Tonight's video is on section 3.3, the first derivative test. The homework out of 3.3 is 17 through 45, every other odd. So the first derivative test is in order to find relative mins and relative maxes on the original function. What you're going to do is you first need to find your critical numbers. So let C be a critical number of function f that is continuous on some open interval on f, call it I, and it must contain C, my critical number. So number one, if f prime of x changes from negative to positive at x equals C, my critical number, then f has a relative minimum at that point. So at C, and then you put C into my original function, you get that ordered pair. That's where the relative minimum is. For example, there would be my original function. If f prime of x, again, that's not what this is. This is f. This is f. If f prime of x changes from positive to negative at x equals C, then f has a relative maximum at C, f of C. In other words, if it goes from positive to negative, then take that critical number, put it into the original function, you get the ordered pair on the original function. This is C, f of C. 3. If f prime of x is positive on both sides of C or negative on both sides of C, then f of C is neither a relative min or a relative max. And so here are a couple of examples of my graph of f where there is a there is a critical number C, and we found that through undefined, but it's not a relative min or max. You can see that that function is completely decreasing or that function is completely increasing. So that defines the first derivative test. Let me give you steps on how to do it, actually. So I'm going to take it and formulate into steps. So steps to use the first derivative test. And I'm going to use these over and over again on the two examples I'm going to do in your notes today. Number 1, take the first derivative. 2, find your critical numbers. I need those. So we've already learned that there are 2 ways to get my critical numbers. I take my first derivative, I set it equal to 0, find what values of x make this true. Those are critical numbers. Also, if I have some kind of a rational function, I have a denominator, I'm going to find out what x values in my first derivative is going to make it go to undefined. So then I have found my critical numbers. The next thing I'm going to do is I'm going to evaluate that critical number. I want to find that ordered pair back on that original function. So I'm going to use this and let it sit here. These are possible relative mins or maxes. They might not be, but they're my possible because I found the critical numbers from here. Next thing I'm going to do is I'm going to create a sign chart like we did in pre-calculus. We're going to create a sign chart with these critical numbers, and we're going to put test values for the slope of the tangent line on either side of these critical numbers. 5, I'm going to test those slope values back into my original function and find out that if it's positive or negative. We're going to test those values in my first derivative to find out if it's positive or negative. 6, this is how you're going to write the conclusion, and then you're done. Since f prime of x changes from, and you're going to find that out here, from positive to negative or negative to positive at x equals C, that's not a 0, C, whatever that is, then f has a relative min or max at whatever that ordered pair is. And we found that ordered pair already in 3. We set ourselves up for this answer. But again, we found out on the previous page, if it goes from positive to positive or negative to negative, then there is no relative min or max at this ordered pair. So let's see these steps in action. I'm going to do 2 problems that you are not assigned to do. Number 19. Here's f of x. It's some quadratic, some parabola. Step 1. take the first derivative. All I'm going to do is find the relative min or max. That's a quadratic. We can probably find that quite easily, but we're going to use calculus in order to find it. So I'm going to take the first derivative. Step 2, to find my critical numbers. Well, I'm going to go ahead and set it equal to 0. Go ahead and solve for x, and x equals 1. So that means I have a critical number here. And then there's no way to get a critical number the second way by seeing what values of x is going to make this go undefined because there is no denominator. Sorry, you can't even see that number. That's a number 3. Step 3 is to take my critical number, evaluate it back into my original function, just so I can get that ordered pair. So that is 5. So I'm going to make that ordered pair 1, 5. So back in my original function f, this ordered pair 1, 5 could possibly be a relative min or max. Let's go ahead and continue through the steps to find out what it is. Either it is or it is not. Step 4 is to make that sign chart. So I'm going to make my sign chart, which is really your x-axis. Below, as I did in pre-calculus, I like to put my critical number below. Then on either side, I'm going to go ahead and have a test value. Well, the two easiest ones would be 0 and 2. And so all I want to know if it's plus or minus. I just want to know how the sign changes. And this is a first derivative sign chart. Oh, and I wrote that here, sorry. And so let's put in 0 into the first derivative, which is here. You put in 0, I'm going to get a positive output. I'm going to put in 2. Well, that's negative 8 and a positive 4. That's going to give me a negative output. So at this critical number 1, on my first derivative, it goes from positive to negative. So what that means is the slope of the tangent line is positive, and the slope of the tangent line to the function of f is negative, which means f is increasing and f is decreasing. This was me getting those positive and negative outputs. I went ahead and did that already, step 5 in my head. So now I'm ready to draw a conclusion. So let's see what it said back here. No, if it goes from positive to negative, here it is, step 2. What do I have? A relative max. From positive to negative. In other words, positive means on my function f it's increasing, negative means it's decreasing. So here's my conclusion that you must practice writing for your AP test. It says f prime of x changes from positive to negative at x equals 1. Then f, my original function, happens to have a relative max. Where? At 1, 5. Let's try it one more time. And then I'll be done. So my original function f of x is x to the 1/3 power plus 1. So step 1, take the first derivative. And I did so. And I cleaned it up. Step 2, find my critical numbers. So I'm going to try setting this function equal to 0. Find where's the slope of the tangent line equal to 0 at what x value. So in doing so, I'm going to multiply both sides by this, except then it says 0 is equal to 1, and that is not true. So I get none from setting it equal to 0. Next, I'm going to try to see what x values is going to make this first derivative undefined. In other words, what's going to make this equal 0? And so that would be 0. So I do have one critical number, and it is 0. So in step 3, I'm supposed to evaluate that critical number into my original function. So 0 to the 1/3 power plus 1 is just 1. So my ordered pair is 0, 1. So at 0, 1 on my original function, I might have a relative min, a relative max, or neither. So in step 4, I'm supposed to make a sign chart like we did in pre-calculus. And this is my first derivative sign chart. So my critical number is 0. And I'm going to have a couple of test values. I'm going to pick one on either side, and I usually put it above, -1 and +1. So again, I'm telling you what I wrote here. And then I answered this from going down here already. So again, I've already done my notes in advance. I'm going to test out -1. I get 1/3. That's a positive answer. It's positive here. I'm going to put in my test value of 1 into my first derivative. By putting in 1, I also get a positive output. So let me take my first derivative again. Look what it says. Is f prime of x is positive on both sides, then f of c is neither a relative min or a relative max. So I already know this conclusion. Since f prime of x is positive on both sides of x equals 0, then there is no relative min and no relative max. Thank you.